a lot of buzz going around in the market for artificial intelligence, machine learning, deep learning, data science. These are all buzzwords, but we will take a 30 minutes to understand what is artificial intelligence, machine learning, deep learning, and data science. And then during the process, we're going to debunk artificial intelligence myths, AI model flowchart, how you go ahead and design your first machine learning AI model. Then what are the limitations of AI? Then computer vision examples. And then we are going to talk about AI kickoff, how to start AI kickoff for your organization. 30 minutes. So what is machine learning? Let's compare machine learning approach as compared to other applications, legacy applications or Java application or .NET application or any Angular JS application you have been writing. So other applications, what you do is you provide an input and then you write code for doing some operations like updating a database or showing something to user based on a click, and then an output is generated. In machine learning, it's a slightly different approach. In machine learning models, what you would do is you will provide input and observation. So what is the input and what would be the output slash observations, and then let the machine write a model based on input and observation, giving you multiple examples. So speech or voice is input and observation is command recognition. Emails. So if you provide multiple emails with labeled data, like this email is a spam, this email is not a spam, you would have observation, the models or application as virtual assistant. So virtual assistant or spam filtering. So based on the data input you provide and observations, you would create a model. I'm going to give you an example in the next couple of slides. And then these examples, which I just talked about, are examples of artificial narrow intelligence, meaning that all these applications like virtual assistant, spam filtering, predictive analytics, online ads, based on what are the chances of a click, based on user profile and advertisement type. So all of these machine learning AI applications are examples of artificial narrow intelligence, which is specific to a task. It cannot be a Terminator type of movie wherein it can do everything from riding a bicycle or a motorcycle to driving a car or flying a plane. It cannot do everything. So artificial narrow intelligence, all the applications which you see today are artificial narrow intelligence examples. So let's talk in detail. All of these applications on ML, what we talked about, are part of artificial narrow intelligence, which means they are built to do a specific task. So artificial intelligence itself is divided into two categories: artificial narrow intelligence, we have been talking about, and artificial general intelligence, like Terminator type of movies, robots doing everything, having emotions, multiple skills, multi-talented. At this point in time, it's just in movies. They do not exist today. And that is few myths we are going to debunk on our way. So let's talk about some myths which are going around in the market. They are not true, 100%, right? So artificial intelligence myths. The Terminator movie type scenario, can do everything a human can do or even more, does not exist. It does not exist today. And in the foreseeable future, let's say 20 to 40 years, it is also not going to be possible based on the current understanding of multiple scientists I have been talking to. Now, think about this. I'm not saying that there are no robots. Obviously, there are robots. Again, they are ANI, artificial narrow intelligence. That means they're doing a specific task. For example, visual inspection or bringing a glass of water to you or personal assistant like Alexa. But they cannot do everything. If you ask me, Alexa or Google Home Mini or Home iPod from Apple, they're all part of what we call it as very specific task, maybe a Google search based on your voice. That's pretty much I would call it. AI works in the same way as human brain. It does not. We have a very close resemblance, what is called deep learning, and I'm going to talk about deep learning in a few minutes, but it does not work as what human brain can do. Super robots, killer types are coming soon. It's not. Nothing is going to happen, at least from a killer type or man versus machine survival war. There is nothing going on at all. Other than this, there is a common belief that artificial intelligence or machine learning is going to take away my job. Of course not. In fact, there are a lot of analysis being done, and what they're talking about is rather than automating jobs, they're automating tasks. So, for example, a company secretariat, or receptionist, she does multiple tasks like aligning up papers, taking phone calls, greeting visitors, and as well as scheduling meetings. For it, but these tasks can be automated by itself, but the role of receptionist itself may change. Receptionist can do something better and more human rather than more machine like repetitive jobs. So a task is being automated, not the job. In fact, there would be more and more jobs creating. The way we work today will be changing. Think about this. 200 years ago, everybody, literally everybody, knew how to ride a horse. Today, I would say only 2% or 3% of people know horse riding, but almost 95% of people know a car driving. In 200 years from now, who knows? There will be autonomous cars, and 2% of the people would know how to drive a car which is not autonomous, right? So things change. The way we do things would change definitely. Intelligence machine can learn on their own and it's free of bias. It's not. We're going to talk about in the limitations of AI that how biased an artificial intelligence can be because it's input and output or input and observation. So I'm going to talk about that also. Many people think that my business is, yeah, I do not know AI, they do not need AI. If you think that, most likely you are doing harm to your business. AI is not a dream, it's a reality. It's already there. And AI is not for tech elites, which cannot make human obsolete at least for the foreseeable 40, 50, 60 years. It's not going to happen. And these are some myths which are going around in the market and it's not true. Now let's talk about very common use of terms like machine learning and data science. A machine learning engineer may or may not be a data scientist, or a data scientist may or may not be a machine learning engineer or a researcher. Let's talk about it. So, this is an example. The first three columns, area in square feet, number of bedrooms, and furnished or not, define the price. So, in this case, price is an observation, and these three are inputs. If you look at it, 1100, these three lines have the same area with different bedrooms 233 and furnished or not furnished with a different price. Now let's talk about it. This is input and this is an observation. So machine learning, what it can do is you will provide input and observation. It will train a model, and then based on the model it can predict the price of a 1500 square feet home for which the price is not listed. And then it can say, hey, 1500, number of bedrooms and furnished or not. Based on this, think about a linear regression or a regression algo problem which we solved in our mathematics days. Now data science approach is different. What they do is it's a science of extracting knowledge, business knowledge and insights from the data. Suggested hypotheses. So a data scientist will suggest a hypothesis. Think about this. If the area in square feet is the same, but if the number of bedrooms are less, you're going to fetch a lower price. However, with the same number of area and the same number of bedrooms, with a furnished home, it's going to fetch you a higher price. That is what furnished homes have 20% premium. Homes with 3 bedrooms are more expensive than 2 bedrooms. So data scientist approach thinking and output would be different as compared to a machine learning algorithm. Now let's put all of these things together. So how does artificial intelligence work and how everything fits? So artificial intelligence is the biggest bucket and machine learning forms the core of artificial intelligence. However, not all algorithms or not all programs are machine learning programs. Let's talk about it. Deep learning is a specialized form of machine learning with activation nodes or activation nodes called as neurons. So activation nodes called as neurons, and this is very close analogous to a human brain neuron. It is not like a human brain, but it's based loosely based on the concept of how human brain works. We're going to talk about deep learning in the next few slides. Data science is a separate field. A data science program may or may not be categorized as artificial intelligence or even machine learning. There is an intersection, of course. So, data scientist or a machine learning person can do either or, but there is a separate field of study of data science, and machine learning is totally different. Then you have chatbots, RPAs, virtual assistants, and robotics, which all are part of artificial intelligence. They may or may not be machine learning. On top of it, you must have heard about supervised learning, unsupervised learning, and reinforcement learning. You also must have heard about GANs is generative adversary network, which is to synthesize some lip movement. Look it up on the internet, search for GANs and Obama, and you would see a fake video of Obama saying something which he never said. And then you would also hear some terms like TensorFlow, Keras, MXNet, Caffe, PyTorch, Scikit-learn, R, and Weka. These are all machine learning framework. Please note that R is a language and also be classified as a library or a framework. Same as Weka. All of these can also be enabled through Python. So Python is very commonly and widely used machine learning language. I hope this is now clear. Let's move on to how to write a machine learning or a model flowchart. This is a flowchart on how you go about writing a machine learning algorithm. So you start. The first step is to gather data. You understand where the data is coming from, gather the data set, and then split the data. Splitting is required in order to train and test your model. I'm going to talk about it. So 80% and 20% split for train and test. You would use 80%. You can do 70-30 or 75-25, does not matter. So has target. In the example on the area and the furnished bedrooms and number of bedrooms as well as the price, the target variable or the target which you are trying to predict in a machine learning algorithm was the price. If you do not have a target, that means you do not know what to do and just want to explore, then you would do an unsupervised learning. We're not going to talk about unsupervised learning now. We're going to talk about supervised learning, meaning you have a target. Now, the target can be of two types. The first one is continuous. That means it can have any number, numeric. So, for example, price is a continuous variable. The price range can be 150,000 or 100,000 or 1,500 to 250,000 to 300,000 and whatever. So it can be any number. The range is not defined. However, discrete means you have classes, class A, class B, class C, or furnished a flag, yes or no. So class 1, class 2, class 3, type 1, type 2, type 3 are all discrete. So if you have target, then you would identify if it's a continuous, that means numeric, or discrete means class. If it is not continuous, or if it is continuous, then you would do classification for discrete and regression for continuous. Is it continuous? Yes, regression. If it is not continuous, then classification. Algorithm. So these are algorithms. We are not going to talk about this algorithm in this session. And then classification and regression, you would start training the model. You would write some Python or some kind of a code to train the model. The model is going to take in input, an observation, and create a model which is an equation, a mathematical calculation formula in order to provide an input based on the input and observation, derive the formula, and then formula can be used for predicting inputs based on the target. Sorry, predicting target based on the inputs. Now, the trained model is there, and then you have to test the model. Now, the test data is going to come into picture. And then again, you have to find out if it's continuous or not. If it is not continuous, then you would use confusion matrix to validate, test the accuracy of model. To test the accuracy of model, you're going to use confusion matrix or root mean square error for continuous variables. For discrete, confusion matrix. For continuous, you are going to use root mean square error. Or there are multiple other things, but this is very basic, very generic model flow. And then end. Please note that there are a lot of other things like hyperparameter tuning, normalization, standardization, feature scaling, uh, principal component analysis. There are a lot of other things which you would do, but this is the core, very generic form of model flowchart. In the next video or other videos, we are going to talk about uh, how you can add more complexity to this model. But this is the basic of machine learning. Let's move on. So I'm going to talk to you on an example wherein we are going to automate a task of visual inspection. So think about a factory line where you are having 3 or 4 people doing a visual inspection of the number of the bottles, if it's good bottle or a reject. So you're going to gather the data. Remember the first step, gather data. So this is a good bottle picture. So input, observation, input, observation, input, observation. So now you have gathered the data, input and observations. This is a classification algorithm because it can be good, reject, good, reject. There are 2 classes. And next you train the model. So good and damaged bottle identification. And then you deploy the model using APIs, which is application programming interface. So basic, gather the data, train the model, deploy the model. So if you look at it, this image is reject because you have a defect over here. Next, how do you go about it? So think about automating tasks rather than a job. You don't want to automate a job. You should think about automating a task. What are the main drivers of the task? The main drivers of the task are to automate and make the visual inspection of these images or bottles to be human error free. Imagine the 3 or 4 or 2 or 3 people doing the manual visual inspection can do some better things. They can be released and can do some better things which can be helpful in retaining those employees with a better job satisfaction. Next is steps of an AI project. We just talked about it. Gather data, train model, and deploy model. And then finally, insufficient data, mislabeled data, or ambiguous labels are some challenges of AI. We're going to talk about it in limitations of AI. Next is deep learning. I'm not going to take you very deep into deep learning. I'm just going to keep it at a very high level. And then we are going to do a separate video on deep learning itself. So algorithms that try to mimic neurons of the brain. We call that as activation node or activation function for neurons. Uh, so artificial neural networks are answers to make machines more human-like. It's not going to replace or compete or fight against humans. It's augmenting the task which humans are doing by neurons, which are artificial neurons, which are arranged in series of layers. I'm going to show you a diagram as well. And then artificial neural networks use multiple layers of mathematical processing to reach to a conclusion. Think about image recognition. Based on the images, you would train multiple neurons, arrive at a model which is nothing but a mathematical calculations to identify if the picture is good or bad, if the bottle is defect or a good bottle. So this is how a deep learning neural networks looks like. So you have input and output. Let's talk about a very simple mathematics, which is and, the and function. During our college days, we might have school days, we might have understood 0001 1011. These are the and. What would be the resultant? Let's do a very small exercise of an and activation function. So you have x1 and x2 as input, and x0 is a constant. These lines are having different weights. Weight 0 for x0, weight 1 for x1, and weight 2 for x2. These are some arbitrary numbers which we have taken into consideration. And this s of h of x is going to be an and activation, logical and activation function. So h of x is going to look like w0 multiplied by x0, w1 multiplied by x1, and w2 multiplied by x2, where weights are as defined, 15, 10, and 10. I'm not going to go in detail as I mentioned, but g is a sigmoid function. Look it up on the internet, or I'll do a separate video on deep learning. G is a sigmoid function. It has a different graph. So I'm not going to talk about that at all. So if you look at it, this is a sigmoid function which can help and activation. Not in detail, at a very high level. Now, let's talk about limitations of AI. There are a lot of limitations of AI. So AI can learn from observations, but they cannot provide a reasoning for classification. So if you are human, or humans can think that why this is a defect, but then AI cannot tell you why the bottle was reject or a defected bottle. They cannot be descriptive. For example, if you want AI or machine learning to write a review for a product, it cannot do that. Machine learning or deep learning algorithms need a lot of data to learn. They need a lot of data to learn. AI can be easily biased based on gender, color of skin. AI is an iterative process and it takes time for AI process to mature. The first attempt, it may not be a right or 100% effective. And adverse attacks on AI are really easy. So adverse attacks meaning there was a case wherein they were trying to do an autonomous car wherein the car used to or needs to identify stop sign and stop at the sign. If you look at stop sign, it is red and stop written in between with a white. If you put a sticker or some kind of a other color in the red area of the stop sign, the car was not able to identify. If you look at it, nobody touched the model, but the input which was given did not match to the input the model was trained on. So input was stop sign with some kind of a sticker or some yellow, blue, whatever color sticker. But a human can understand, oh, there's a sticker and it's a stop sign. But an autonomous car where you train the car with a regular stop sign may not be able to identify that it's a stop sign or not. So it's a very easy to attack. Limitations of AI is ambiguous data. Remember, ambiguous data, insufficient data, and mislabeled data. Now, so let's assume that we have these images which we trained the model to, and then we have more images for which you retrain the model. But if you look at it this time, we have this is mislabeled image, ambiguous, and insufficient. Why this is a reject? So if you provide this type of data set to an artificial intelligence algorithm, the artificial intelligence model is not going to work because it's now confused. Because one time this is a good reject, another time this is good. It's now confused. So there are a lot of limitations. You need to have a good data set. That does not mean that you need a big data or a data big data or a data lake kind of a solution. You do not. Now, I'm going to talk about AI thought process, what you can think and how you can kickstart AI in your organization. So think of inducing AI into your legacy systems. If your legacy system is Java based or .NET or any other programming based where APIs are possibilities, then you can think of creating a standalone AI application and linking the legacy application to the AI application using APIs. And I'm going to show you in a few minutes. No project is too small. So we go with an assumption that start small, but no project is too small. Start with a project which can give you immediate success that can lay that confidence in your organization. Don't expect all the AI projects to work the first time. Please understand there are a lot of limitations on AI, especially around data. Plan for AI development to be an iterative process with multiple attempts. Think open source platforms. These are some good way to start. I'm not saying that you cannot use IBM Watson or Azure machine learning services or Google or AWS machine learning services. You can always use them, but think about open source platform because there is a lot of open source community like on Python, R, and other languages. You do not need a data lake or a big data for an AI strategy. So should be your thought process in the next step. Obviously, traditional planning process also works with AI projects. So you don't need a different planning process. Of course, the, the outlook would definitely be different. Now, how do you start using AI to transform your company? AI technologies can only deliver value if they are part of organization strategy and used in the right way. This is by Alexander Linden. He's a research vice president at Gartner. Fail fast, learn fast approach. Start quickly, fail, understand what went wrong, and redo it because it's an iterative process. You want to not spend too much time in just doing one thing 100% right the first time. You start, fail somewhere, redo it. It's an iterative process. Gain momentum by executing pilot projects. Pick those low hanging fruits or low hanging tasks which can be automated or can be augmented or change the way how they are working with AI or machine learning algorithms. Assemble a small but an in-house team. Many people look for outside help. Definitely you should if you do not have AI capabilities in-house. But then your in-house team members know the data and the task much better. Conduct AI trainings and brainstorming sessions, and then develop a short-term and a long-term strategy. So let's talk about it. This is how you can enable your legacy applications on AI. So let's assume that you have a loan application or any other legacy application. Then you create an AI application which is standalone by itself. Obviously, you enable them with API and make a call through API. We have done that at multiple client places. You have AI application should be part of your existing legacy application. You don't need a fresh investment, but then the small connectors can definitely help. Think about this as one of multiple options for a solution. What I would suggest is you do not want to ask for separate funding from your management. You may want to start small. Think about open source, that's what I said, without incurring any licensing cost. Fail fast, learn fast. It's important for the initial projects to succeed rather than being most valuable. Create a prototype rather than just a slide. Visualize and understand the feasibility of the projects. Fail fast to achieve greater results. And 4 to 6 of efforts, which I'm thinking for this particular case, executing pilot projects. Now, assemble a small team. As I said, this should be your team. AI project managers, product manager. He's going to be like the project manager, data scientist. Now you know what is the difference between a data scientist and a machine learning engineer. Data engineer to get your data and make it available for data scientists as well as machine learning engineers. Then you also need a researcher in your team, which can also be an engineer, but then do a lot of research, should have that outlook, a mindset of a researcher. And do not underestimate software engineers. So this should be a very typical team. Obviously, a person can play multiple roles, wear multiple hats, but think of a very similar kind of a team structure. Then AI trainings for executives, managers, and AI engineers and technical resources. These this material is taken from Baidu.com, and I'm kind of put together multiple things. Brainstorming sessions, due diligence on the project. There are two types of due diligence: machine technical due diligence and business due diligence. Technical is more around data, AI system performance, and business is how you can increase revenue, lower cost, and think of tasks to be automated. Build versus buy. If there is something available in market directly, why to reinvent the wheel? Go get the product. Do a cost benefit analysis, data science projects, and industry standard. If it is available, go buy it. Next, develop a long term and a short term strategy. Think about automating tasks rather than jobs. Define main drivers of the tasks. Consider creating a data strategy for a long term vision. And then, how to leverage AI. Think about how you can be a fierce competitor in your industry sector. And then it's a virtual circus of AI, cycle of AI. More data means better results. Better results mean more and more users, which can again give you more data. So it's a circle. You start with one and obviously churn it over. Now, initial steps which you can take today: conduct a deep dive training session, start brainstorming projects, put some thought process. How can your company be much more competitive, valuable, and effective with an AI initiative? Hire a few machine learning and data science people to help, and then discuss with the CEO and business of the possibility of AI transformation. There are multiple use cases around the board, across the board for marketing, finance, manufacturing, HR, and healthcare. You may want to start with one of these, or there are multiple others available. Thank you. Thank you. I hope this was informative. There are a lot of technical deep dive things which we are planning to conduct. Subscribe to this channel and keep watching. Thank you.